talking about cloud chaos and microservices mayhem. So you can see the theme for this room is cloud and alliteration. So let's talk about cloud. I think cloud, I sort of feel, that this is a great time in software engineering, that we're really lucky to have the cloud. There's so many things that used to be so tedious for us that the cloud just makes easy. And there was so much work of provisioning machines and managing machines and sort of jostling with colleagues to see who could have the most boxes sort of stacked under our desk, and then trying to maintain them all and trying to patch them all. All of that has just gone away. And so we have this really wonderful frictionless compute power at our fingertips. So it's all good, right? Well, not quite. With the cloud, there's definitely good things, but what we're also seeing is there's opportunities to get electrocuted. There's all of these challenges with the cloud that we just didn't have before, that now we need to try and figure out. And it seems like, although some things are frictionless, actually the load on us as developers is getting higher, not lower. So if you look at the kind of things that, as a software engineer, we need to have a handle on in 2022, well, the first thing is hand washing, because 2022. But there's a whole bunch of other things as well. So we need to be doing apps. That's our job. But then now we need to really be pretty good at the ops side of it as well, or we're not doing our job. And then, of course, once you combine the application development side of it with the ops side of it, then we've got DevOps, and we really need to be doing that. And then, of course, DevOps without the security, maybe not quite ideal, so we need to be doing DevSecOps. And then DevOps and Sec, but without the business. Well, that's not probably ideal either, so we should be talking to the business, so then we get DevSec, BizOps. And I won't go through every single variation of this, because it just gets quite long. But then, of course, as well, we need to be thinking about FinOps, because cloud costs, even though it's frictionless. So the cognitive load seems to be going up and up and up. And so then that can leave us as developers kind of going, oh, everything I thought I knew about software engineering is different, and what do I do? So I want to talk about some of the things that can go wrong in the cloud, some of the things that are different in the cloud, and then as well some of the things that we see when we do microservices that go particularly wrong. And I kind of, as I was looking at this talk, I was thinking, is this really even a relevant talk? Should you all be here? We've been doing mainstream cloud now for 10 years, and it's pretty sort of inane to stand up here and say, hey, let me tell you about something about technology. Technology changes fast. Did you know? And you're all there like, yeah, technology changes fast. Technology has always changed fast. It's the nature of technology. But I think even in this technology world that changes so fast, it's a bit surprising how fast cloud has changed things and how much cloud has changed things. And you can see the evidence for this when you look around the ecosystem. Because even though we've been doing mainstream cloud for 10 years, there's still a bunch of things and a bunch of tools and processes that completely have not caught up with cloud. So this is still a relevant conversation, even though maybe you might have expected it wouldn't be. But I'm going to start with some of the good bits. I'm going to start with some of the things that have changed, but we're more or less on top of it. So in the old days, we used to talk about tracing. Then we realized, well, tracing isn't really enough. We need to be thinking about tracing and logging and metrics, and then that's kind of a bit of a handful, and actually let's call this observability. I think we're sort of, we all kind of, certainly all of us of a certain age had the experience that, the old way we used to do it was we'd have our application and we'd have logs that would go to the physical machine or to the virtual machine, and that was okay. And now what we have to do is, in the cloud, we tried the same pattern, but there was a problem, because that container went away. And as soon as the container went away, the logs that were in the container went away too. And then we kind of went, I'd really like to know what bad thing happened to take it out. And the logs are gone. So it was a problem. So now we have to do different things. So we have our logs. They may be in the container somewhere, but it's really important that we get them out of the container, so that if the container goes away, we've still got logs. And of course, we've got lots of containers, and they're all going to go out of their containers, and then we've got this big pile of logs. And if we have hundreds of microservices, trying to understand what was happening across all of them is challenging, so then we need to do some kind of aggregation and correlation. But I think we are in a really good place for this. With the sort of the integration of standards across all the different vendors, it's a bit of a golden age of observability. What's maybe a bit less good is when I've been in observability talks, and the speaker will talk about everything, and okay, who here knows these ideas? Yes, yes, yes. All the hands go up. So who here has observability in production? And everybody's kind of sitting uncomfortably on their hands, except for the one person. So just to sort of sense check for the non-observability audience, how many of you have observability solutions in production? Oh, hey, excellent, well done. Okay, so we can ignore the next bit of this slide. You all are awesome. It's everybody else who's not keeping up. So let's talk about something that's maybe a little bit less fixed, a little bit more in flux, which is how do we think about what we need for performance? What does a good machine look like? What does a bad machine look like? In the cloud, memory footprint is money because you are paying per gigabyte of memory. And startup time is money because instead of starting this thing once and leaving it for 6 months, it may be going up many, many times. I heard recently an example, and they were doing continuous deployment, and so they were deploying about every 5 minutes, and so every time they deployed, the servers, they weren't using serverless, but just because of the rate of deployments, it was still going up and down all the time. So that startup time really, really starts to matter. Now, how many of you are Java folks? Most of you. Good, good. So we are seeing changes in the Java ecosystem. If you look at something like serverless, Java has historically been really bad for serverless. It had about 6% of the market, but it's changing. And those changes that make it good for serverless also make it good for everything else, I think, certainly the developer experience and everything. So I now work for Red Hat. I work on the Quarkus team. I actually wrote this slide before I worked for Quarkus, but I liked it so much, I went and joined the team. But I think it is really exciting. So what we're seeing here is that ahead-of-time compilation and doing more things up front used to be a really bad idea. And I used to work as a Java performance engineer, and people always used to say, couldn't we do ahead-of-time compilation in Java? And I used to say, no, it seems like a good idea, and it's really not a good idea. That was 20 years ago. Now, doing as much as possible ahead of time and limiting the dynamism makes it much more well-behaved in the cloud, so it's a good idea. So what about performance optimization? So that's the sort of the performance requirements. What do we want from our servers? It used to be that we wanted to optimize for throughput after about 4 months up. Now we want to optimize for footprint, startup time. So how do we do this optimization? How do we tune our systems? This is an area where I think, wow, excuse me, the stage just collapsed slightly on me. I'm just going to stand here. You think when you're standing on a stable surface, you're safe, but nowhere is safe, which is a little bit related to what I'm going to talk about here, which is that the best practices and the ergonomics for making a JVM behave well still have a lot of kind of institutional knowledge and ecosystem knowledge from 10 years ago. And so we always say to people when they're talking about performance tuning, don't go and try and do all of this manual tuning. Don't take that big, long string that you found on Stack Overflow for how do I tune my JVM and paste it in, because it's not going to work. You're going to be better off with the default, because the JVM vendors design these things to work best in the most common case. Sadly, much as we all want to be snowflakes, your case probably is a common case. So if you do nothing, you'll be in a great place. But that's it's sort of mostly true, but it's not actually true. So my colleague, Ben Evans, he wrote a good article recently because he was looking at how does the JVM decide what it should do. And the JVM, if it detects it's in a server environment rather than like a desktop environment, it will set different defaults. And so then the question is, what is a server? How does it decide what's a server? And it can't do, the sort of the intuitive thing of like peering outside the box and looking to say, am I in a data center? I could see a whole bunch of stacks and it's kind of dark in here. I think I'm in a server. So it has to kind of just look around its little box and try and guess from that whether it's a server. And so the heuristic it uses is, if I'm in a really big machine, I'm a server. If I'm in a small machine, I'm probably client-side. And that is actually pretty much the exact wrong heuristic in 2022. So for our laptops, for example, how many people have an 8-core laptop? Like all of us, right? How many people have 16 gig of memory on their laptop, right? Like, yeah, 32, 64. Our laptop machines are really powerful. How many people are regularly provisioning containers with 32 gig of memory? Like, only very, very rich companies, right? Because a 32 gig container is expensive. You go for as small as possible. And then, if you've got like a cool modern JVM that can run in a tiny little footprint, you go super, super extra small. But unfortunately, the JVM hasn't caught up with that reality yet. So if you look in the JVM source code, you see that what it does is it says, if I've got more than 2 CPUs and more than 2 gig of memory, I must be in a server. But in fact, if you've got that, you're probably on a desktop. And if you've got less than that, you're almost certainly on a server, because all laptops have more than that. So does this make a difference? Well, yeah, it totally does. So for example, it will choose the garbage collection policy based on whether it's in a server or not. And for reasons I don't totally understand, it decides that if it's on the desktop, it will go for longer pauses, and if it's on the server, it will go for shorter pauses. Leaving aside the reasoning for that decision, what it means is that if you run it in a small container, you're going to get a different garbage collection policy, and your pauses are going to be way longer, which possibly isn't what you want. And so this is just so, this is kind of interesting, but it's also just so counterintuitive, because it's one of those ones where you would have thought that you could have trusted it to do the right thing, and it kind of does the wrong thing. So the takeaway is that if you shrink your containers too much, which is the right thing to do economically, you then need to kind of look and say, well, wait a minute, have I just made something weird happen? Has it just helpfully switched the GC policy on me because it doesn't know that it's possible to run Java in a container that small? So you'll notice that I started out by saying, we can run Java in really small containers. It's amazing, we can go smaller and smaller and smaller, and this is so cool. And then I said, but don't go smaller and smaller and smaller, or bad things will happen. So I have now given you 2 contradictory pieces of advice. And I think this is where we get to the kind of the chaos part, right? We have, even though we've been doing cloud for 10 years, we still have these situations where it's not totally clear what the right thing to do is, because the ecosystem is still figuring it out. So let's talk about management. And by this, I don't mean people who tell us what to do. I mean the art of keeping track of our hardware, which is definitely, unfortunately, an art. Because the joy of the cloud is it makes it so easy to keep track of our hardware. Or sorry, the joy of the cloud is it makes it so easy to provision hardware. We can just go and we can spin things up and we can spin things up. But of course, we have to keep track of it, and that's kind of hard. And we have to keep track of it because just because it's frictionless to spin something up doesn't mean that a bill for it isn't going to hit someone who's probably not us, but who may be our boss. And there's other problems too, because this hardware that we spun up, sometimes it's useful, sometimes it's running our business, but sometimes it's actually not. Sometimes we just forgot about it. And we can't rely yet on systems that say, you know what, I haven't actually done anything useful for a long time. I'm just going to shut myself off. It doesn't happen. And I think we've all had this experience. So when I was first learning Kubernetes, I created a cluster, as one does, but I had too much work in progress. So I kind of forgot my cluster for 2 months, and I went off and did something else. And then I went back and I looked at it, and I realized it hadn't done a thing for 2 months. And it was kind of a well-spec'd cluster, so it was €1,000 a month for this cluster that had just been burning IBM's money for no reason. So it was a sort of a slightly awkward conversation with my boss about like, oh, yeah, oops, sorry about that. And this is a problem that the good news, bad news, is that it's not just me, right? Like, this is a problem that we have across the industry. There are zombie servers everywhere. They're using resources, they're costing money, destroying the planet, anything to contribute in any way. Can we quantify it? Yeah. So the best study that I know of was in 2017. They looked at 16,000 servers, and what they found was 1/4 of them were doing no useful work. And you think, imagine if you could cut your cloud bill by 1/4, that would be impressive. And you can. You just have to figure out which 1/4 of the machines to shut off. And with these servers, that is exactly the problem. The authors sort of said, why is this happening? People forgot to turn them off. So this is where we're seeing the new discipline of FinOps coming in. And there's a fancy name, description for FinOps, which is using the real-time information and trying to get some of that automation and real-time data flow to finance, which is famously not very automated or very real-time. But I think it's mostly, for us, the relevance is that it helps you figure out who in your company forgot to turn off the cloud. And it really, really matters. So there's sort of a new genre of horror stories on Twitter, which is companies that forgot to turn off the cloud or had some other cloud accident. And the bills are big. So there was a little startup, and they had, little startup funding, and they were doing some testing, and they thought they were on a free tier, and they made a change on a Friday and then went home for the weekend, and only when they got in on Monday did they discover that they had a bill for $72,000 because they'd been helpfully, as soon as they started to exceed the usage limits that they'd set, they were bumped up to the next tier, which was kind of thanks for that. That wasn't why I asked what I asked for. I was hoping to stay on the free tier. And it was like a little infinite loop or some, other dumb problem. And they basically went out of business because of this bill. I think they did manage to get it refunded, but it was a close-run thing. And this can happen even to really experienced people. So Troy Hunt, who does HaveIGotOwn.com, he had a problem, and this one was a little bit more gradual, but he wasn't paying enough attention to his bills. And his bill was tiny, 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 tiny to run that site, and then all of a sudden, it went up to $11,000. And when he looked into it to try and figure out what had happened, it was this really dumb config setting, which is that he had it caching, but somehow in the cache, there was a default that said, if this file's really large, don't cache it. Why you would have a setting that says, I'd really like to cache the files that it doesn't matter, but if it's large, don't cache it, I don't know. But that's computers for you. So again, he had this monstrous bill. So I said that the contradictory performance advice was the chaos part, but actually maybe this is the chaos part. But of course, it just sort of continues. It used to be that we would release software on physical disks. That was really expensive. It limited how often we can do it. Now we can release software whenever we want. But what I see is that a lot of our processes, a lot of the people side of releasing software, is still tuned for those physical disks. And this, I think, it's about how we release software, but it's also really relevant to microservices, because as an industry, we've shifted towards a microservice architecture. And the reason to do microservices is so that you can deploy them independently. But what we're seeing is that often they're not being deployed independently. So how many of you are doing microservices? Most of you. How many of you would say you're deploying them independently? Yeah, I think maybe about half to a third of the team microservices had the independent deployability. And it's sort of, I think, for those of you who don't, do you want to be deploying independently? Is it something that you're sort of having a discussion about, or are you seeing benefits from microservices without the independent deployability? So actually, that was, you can't possibly answer that with a show of hands unless I rephrase it. So hands up if you are doing microservices, not deploying independently, and really are grumpy about the fact that you're not deploying independently. Yeah, small number of hands. Hands up if you're doing microservices, not deploying independently, and actually you're still seeing a lot of benefits from the microservices, and you're seeing, cool, a few hands. I'd love to sort of go more into that and have that conversation, but I think I've reached the limit of what we can do with shows of hands. So certainly for me personally, I find that the benefits of microservices are mostly about the independent deployability, and I find that a lot of people early in their microservices transformation are not getting that benefit and not planning to get that benefit either. So I used to be a consultant in the IBM garage, and we had a bank come to us, and they were sort of a legacy bank, and their lunch was getting eaten by more modern, more nimble competitors. And so they said, we're moving too slowly. We have this big COBOL estate. We've got to get it into microservices. And so we said, oh, yep, we can help you. And then they added, our release board only meets twice a year. So there is no point in doing microservices if you're not going to release them with any kind of speed. You may as well stick with something monolithic because that has some benefits. So you get the modularity, but you don't get the benefit of the modularity if you're not releasing. And what we often see in conversations with clients is because microservices are so dominant now as an architectural pattern, when we look at our old code, we go, oh, got to get rid of that, got to get to microservices. Well, why? Why are we getting to microservices? Well, I don't know, but we've got to get to microservices, clearly. But microservices shouldn't be the goal of a transformation. Microservices are a means to get to some other goal, whether that other goal is releasing more quickly or having, whatever it may be for you. And what we see is often the reason we treat microservices as a goal is because everybody else is doing it. And we look at Netflix and we say, well, if Netflix are doing microservices and Netflix are really cool and successful, I should do microservices because then I could be like Netflix. And it's like, well, maybe not. And the other thing we see is a conflation of cloud and microservices. We see, if I'm on the cloud, I have to be doing microservices to take advantage of the cloud. Well, actually, no, there's lots of advantages of the cloud, even if you're not doing microservices. And even if you want to be cloud native, that's still not the same thing as microservices. You can be really, really cloud native and have monolithic apps. And there's good reasons not to go to microservices. I was called in to a project, and I landed, and the first thing they said to me was, every time we touch one microservice, all the others break. So if you've been paying attention, you know that this isn't supposed to happen with microservices. The promise is kind of that they're decoupled. But what we often see in practice instead is what is known as a distributed monolith. And so a distributed monolith, in case it's not obvious from the name, is really, really bad. You get all of the problems of coupling, but you don't get the benefits of a monolith. So you don't get that compile time checking to see if the types in one section of the code match the types in another section of the code. You don't get that guaranteed function execution. So if you try and invoke a method, you know that it happened without having to do 82 layers of service mesh and check, and was it there, and have I got the right endpoint, and all of that. And distributed monoliths, they have a way of getting more and more and more and more and more complicated and unmanageable as well. So in the case where every time they touched one microservice, all of the others broke, when I looked into it, I discovered that the domain model was shared across all of the microservices. And they knew this, and they said, well, we don't want to be coupled, so we're not going to have a common library, because that would be a point of coupling. Instead, we'll copy and paste. Sorry, lots of laughter in the front row at this. We'll copy and paste the code across each microservice, and that will mean we're not coupled. Well, no, it doesn't work like that. You are still coupled. You just don't have any compile time checking to help you out. And so the dream of microservices is that each microservice maps really neatly to its own domain. But sometimes that doesn't work out. Sometimes the domain model just doesn't split nicely, or it does split nicely, but you haven't done the work to split it. So what was happening in this case was the domain was shared across every microservice. It was really bad. But more generally, I think because they both start with D, we have a tendency to treat distributed and decoupled as synonyms. They are not the same. You can be really horribly, nastily distributed and still have the most entangled, atrocious, productivity-killing coupling. And then what we see when we get in that situation is problems. So a service will do something, and nobody was expecting it to do that, and the other microservices break. Or, in this case, a lot of the breaks were happening from things like, oh, yeah, I just noticed a typo in our domain model. Let me fix that. That won't affect the other 10 microservices that are sharing this domain model. Yes, it will. So if the solution for this, part of the solution is to think about your domain model. But it's also that you've got to get really good at testing, and you've got to get really good at automated testing. And I find the test pyramid is a useful mental model for this. So the idea with the test pyramid is that at the top, you should have a very small number of end-to-end tests. At the bottom, you should have a very large number of unit tests. And then there's various definitions for what goes in the middle. What I like to put in the middle is contract tests. So how many of you are doing contract testing? Ooh, cool. So often when I say contract testing, I get these sort of blank looks. Contract testing, I think, is something that's not as widely adopted as it should be. And I think one of the nice things about contract testing and all of the others is do DDD. It's awesome. So a nice mental model for contract testing is testing a fire alarm. The most reliable way to know that a fire alarm does what it's supposed to do, which is go beep, beep, beep when the house is on fire, is to set the house on fire and see what happens. If, as your house sort of crumbles into ash, you hear a beep, 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 you know your fire alarm's working. However, you wouldn't want to do very many of these tests. You hope that the fire alarm manufacturer has done it at least once, but I'm not going to do it in my house. So instead, what I do is there's a little button on it, and it says, push here to test it. So I push the button, and it goes beep, beep, beep. The problem is that I don't really care whether my fire alarm goes beep, beep, beep when I push a button. What I care about is, does it go beep, beep, beep when the house is on fire? So I have this sort of, what do I do? And so if you I don't know if you've ever seen one of these machines. If you look at sort of institutions, sometimes what they'll do is they'll have someone who's got, it's like a machine, and it produces smoke, and then it sort of cups the fire alarm, and then it sort of injects smoke, and it sees if it goes beep, beep, beep. So this is a lot more realistic than just pushing the button. It actually detects what I really care about, which is in response to smoke, does it go beep, 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 but without the expense of setting the whole house on fire to make sure. So I'm going to do a little demo. I'm going to show packed contract testing. So for those of you who are doing contract testing, how many of you are using packed? Cool, about 5 hands. How many of you are using Spring Contract? 1 hand. How many of you are using something else entirely? Oh, 1 hand. Oh, cool. After the talk, please tell me what you're using. So, what I've got is I've got a little application. When I originally planned this demo, I was going to do a really big application with about 8 microservices, and then I thought about it, and I thought, do I really want to be trying to manage 8 microservices in a live demo? No, because microservices are hard. So instead, I have the simplest ever microservice, which is one thing on the back end, one thing on the front end. But of course, they still need to talk to each other. They still need to share domain understanding, and there still is a coupling between them. So on the back end, I've got my BFF, and you can just imagine that there's a whole bunch of stuff behind the BFF that I'm not showing. And on the front end, I've got, is that big enough? I'm sure I increased my font just a moment ago, but it looks quite small. I've got a little front end. And so if I start them, on the back end, I can do Maven, Quarkus, dev. So I'm going to show this on Quarkus because Quarkus is cool, but there's nothing in this demo that's particularly Quarkus-y. And then once I've showed it, I can go and I can see my endpoint. And I've got some JSON coming out of my endpoint. And then if I go to my front end, I can do and I can start this is just a React application, and then I've just got Node serving it. And so my little model for my application is I wanted to come up with something quite visual, and I wanted to come up with something that showed a model with different parts, and different services would be transforming it. So the idea is a person goes through their house. And so they, let me just refresh it. So they wake up in the morning, their hair, not good. And then they go to the bathroom, they brush their hair, they go to the kitchen, they eat, so they get a little bit fuller, and then it carries on from there. And so going back to my JSON model, you can see I've got this resident, and they've got various bits of state, so they've got arms, eyes, and some of the state these objects have state, so the eyes can be awake or asleep, the hair can be frizzled or brushed, and that kind of thing. So if I go to my code, I've got this aggregator, and it's showing all of those things. But this get torso, it's kind of, I'm not sure if that's really the right word for what I'm trying to represent. It was more the stomach, right? You eat and you get full. So I'm just going to do a quick little refactoring. And I'm going to call it get stomach. And so I run my unit tests. And everything is good. But if you've been paying attention, you may notice that there's a little bit of a problem. Because if I look to my JSON, now all of a sudden, instead of having a torso here, I have a stomach here. So I've made this change thinking it was just an internal change. It's leaked out into my API because of the Jackson. And so then that means if I look at my application, it tolerated the, the issue, but there definitely was supposed to be something here, and it's now gone. But the problem, the bad thing is that I made this change, and nothing told me I had a problem. The unit tests for the front end will continue to pass because they've mocked that it comes in as a torso. The unit tests for the back end will continue to pass. So what do I do? So this is where the contract testing comes in. So what I can do is I can have a contract test. So if I bring back my contract test, you should be able to see that I've got this contract test. It's got this packed with that's wrapped around it. And that's basically acting as a mock. And it's saying everything I do in here, it's going to record. It's going to act as a mock, but it's also going to record it to a contract. So you can see I'm adding some specifications here. So I'm saying my result is mostly going to be like this expected result. But I'm going to add in a little bit of extra information here too. So this is much more deep than just open API testing. So I'm not just testing that it's got these endpoints. I'm actually testing the semantics of it, and I'm saying I expect it to be this or this. And in fact, I can go further and I can say when it goes to this room, I expect the state to change this way and that kind of thing. So I've got my contract, and if I run my tests, so that's just a JavaScript test file. But when I run my tests, you should see, when I run my tests, that in here, I get a contract. So this is just a JSON file. So far, this isn't helping anything because it's just on the front end. But what I can do is I can copy it to the backend, so I can copy it to the BFF. Normally, obviously, you wouldn't be doing it by manual copying. Normally, you would either check it into the producer's source control, or you'd have a packed broker that everybody talks to say, hey, I've generated this contract. Hey, what contracts should I be sticking to? Now that I've got this contract, on the backend side, I can bring in a test. And the test on the backend is really, really simple. So what I can do, I can bring in that test. And you can see, basically, I'm just saying, here is where my contracts live. In this case, they live on disk. Yeah, this annotation is just starting the server as a convenience. And I just want to run the template that packed provide, and please run all the tests. And these tests could be some fairly useful functional tests. So on the consumer side, it acts as a mock. On the provider side, it acts as kind of an auto-magic functional test. So if I don't write any other functional tests, I'm still going to get some quite useful validation. And so if I run this now, the good news is I have a test failure. So I now have an alert that how I think this API should look is really different from how my consumer thinks this API should look, and I need to fix it. So either I could fix it by reverting my change, or I could fix it by going to the consumer team and saying, hey, I really want to make this API change. What do we think? And then we have that negotiation. Some people don't like contract testing because it means you have to have that negotiation to say, hey, we no longer work together. What should we do? But really, if you're doing microservices, you want to have that, hey, we no longer work together, what should we do negotiation at development time rather than at runtime when you just got paged out. So that was the world's quickest packed demo. So yeah, just to summarize, we've got the data model. Consumer-driven contract tests in that case where we had the domain model spread across everything, it was introducing consumer-driven contract tests that allowed us to stabilize the system. And packed, it sometimes can feel like work, but I think it really does give you a lot on both sides. So on the consumer side, it gives you the mock, so you don't need to use wire mock or something else like that. On the producer side, it gives you this functional test. We should always welcome functional tests. If other teams want to write our functional tests, please knock yourself out. And then that shared JSON file allows us to align the expectations between the two services. And with that, I'm done. Thank you very much.